All right, Year 12s, welcome back to remote learning. Today we're looking at exercise 9E, which is all about annuities. Now these are a special type of investment, and they are similar to other types that we've already learned about and some that we're yet to learn about, but we're going to learn a few different ways to analyze these sorts of investments. So by the end of today's lesson, I want you to be able to identify annuities from worded questions, know that they're different and how they're different from the other type of investments, model them using recurrence relationships, and then putting those recurrence relationships into the CAS to generate a sequence of terms. We're also going to look at an amortization table again, and we're going to use the finance solver to do a complex example. So on sector, you should have access to the document, which looks like this. All right, annuities. So it's quite similar to reducing balance loans. So remember, they're the ones that are, for example, mortgages and car loans sometimes look like. The difference is annuities are investments. So you give your money to the bank, not the bank gives you the money to go and buy something big. We can still use amortization tables and finance solver to help us answer questions. However, you have to remember things kind of get reversed because the payments, the bank pays it to you instead of you paying the bank. The balance is telling you how much is left in the account rather than how much you still owe. And the interest rate is what you're earning on the money that's sitting in the account instead of what you're paying the bank, what you owe them. And eventually, just like reducing balance loans, the balance will reach zero. Okay, so just zooming in on how we model it. So this is a recurrence relation because it's got two parts. It's got the part where you state the principal, and then this is what happens with each step. So VO equals the principal, VN plus 1, you've seen that before, it's the next recurrence. R is the rate, V is the value again, minus D, which is the payment that the bank's given to you. So they're taking it out of the loan to pay you, so that's why it's minus. And don't forget to work out your rate, it's just 1 plus the interest rate divided by 100. Don't forget to account for compounding periods. So for example, if it's monthly, you have to divide it by 12. If it's fortnightly, 26. If it's weekly, 52, and so on. Okay, let's have a look at Jack. Now, Jack wants to go overseas for 6 months. He's got $12,000 in an annuity, so it tells us that it's an annuity that earns an interest rate at 6% per annum, providing him with a monthly income of $2,035 per month for 6 months. Model this annuity using a recurrence relationship. So straight away, we know our principal. So VO equals, what was it, $12,000. So the next part of the relation, we work out the recurrence. So VN equals R times VN minus D. So to work out R, we need to use 1 plus R over 100. Now we have to remember that it is compounding monthly because it talks about monthly income there. So we're going to assume it's compounding monthly. So we've got to divide by 12. So the next line is 1 plus 6 divided by 12 over 100. So that means our R is 1.005%. Okay, so we take that 1.005% and feed it into our equation, multiply it by the current value minus the payments of $2,035. Okay, and that's our recurrence. That's the relation. We've got the two parts, and that's what makes it a relation because you've got the principal stated and then you state how it recurs. Okay, so for the next step, you've got to use your calculator to find the value of the annuity after Jack receives 3 payments. So I set it up as VO, V1, V2, V3. I mean, you could probably get away with just writing V3, but just out of habit, I'll put all 3 years. And then we just put it into the CAS. So the first thing we need to put in is the principal, which is 12,000. Then we put in the recurrence. Okay, so I typed in the R, 1.0005, times answer, so it's going to refer to the previous line, minus the payment of $235, and I press it once, twice, 3 times, and we find that he's got $6,000 left after the 3rd month. Okay, I just wrote the values in next to each month and underlined the one they really wanted, which was V3. Okay, part C. Is the annuity fully paid out after 6 monthly payments have been made? If not, how much will the last payment have to be to ensure that the annuity terminates after 6 months? All right, so we go back to our CAS and we just keep entering it. So that's the 4th month, the 5th month, the 6th month, and we can see that there's 88 cents. So we're just going to add 88 cents to the last payment. Okay, so V6 is 88 cents. Therefore, my last payment is the normal payment of $235 plus 88 cents, which is $2,035.88. Done. Okay, so you also need to be able to use an amortization table for annuities. So you can see you've got a bunch of columns here and a lot of numbers, so let's go through them one at a time. So obviously payment number, in this case it represents the months. So this is before he goes on his holiday, and this is the first payment, second payment, third payment until he uses all his money up. The payment received is how much the bank is paying him. You can see it's a regular amount until the last payment. The interest earned. Now, the interest earned, if you look just below in the green bit, it shows you how to work that out. So what you've got to do is you've got to have your interest rate per compounding period, which we earlier worked out to be 0.5% because we divided that 6% by 12, and then multiply it by the balance. So initially, the first one you're finding 0.5% or 0.5% of $12,000, and that's $60. And so that gets written a little higher up. You can see the $60 here. Then, because the balance gets reduced to $10,025, the next time you're getting 0.5% of that $10,000, and that's why this is $50.13 here. So the interest earned will gradually reduce over the lifetime of this investment. All right, the 4th column, principal reduction. Now to work that out, what you need to do is you need to take the payment received and subtract the interest earned. So essentially, it's the 2,035 minus 60 gives us the 1975. If we look at a later column, let me get a different color. Down here at payment 5, we still got $235. This time we haven't earned as much interest because we've got less balance to work with. So Joe's only earned $20.20 interest, which means his loan goes down a bigger amount. It goes down $2,014. So that's why the principal reduction gets larger as you go down the columns. Okay, the last column is the balance of the annuity. So that is representative of how much money the bank is still looking after for you. So initially Joe put in 12,000 and then it gradually reduced month by month. To work this one out, what you do is you take the previous month and subtract the principal reduction, and then that gives you the next balance. So just to go through that, it's the balance of the previous month minus the principal reduction, and that'll give you the new value. Okay, other things you might be asked to work out is the total return of it from the annuity. So that means you add up all the payments and it tells you how much Joe actually got from the bank. And it should be a little bit higher than what he invested because he earned some interest as well. You can see here that it's just the 5 regular payments of $2,035 plus that last slightly bigger payment, and gives him $12,200 overall. To work out your total interest, you've got to do your total payments which is the $12,210.90 from before, minus your investment of $12,000. You can see that he earned $210.90. Okay, so that's how you use an amortization table to do annuities. Okay, you won't always get annuities that last for 6 months or whatever. Sometimes, they'll last for years and years and years. It'll be quite complex and interest rates will change and all this sort of stuff. So we're going to use the finance solver on the CAS. Now remember, if the bank gives you the money, it's positive. If you give the bank the money, it's negative. So in the case of annuity, your principal value or your starting value is negative because you've given the money to the bank. The payments, however, are positive because these are regular payments that go to you, that go into your pocket. And your final value will either be positive or zero because you don't ever end up owing the bank money, so it'll never be negative. All right, so Joe, he's found another $200,000, lucky Joe. He's going to invest it into an annuity, which pays 5% compound per annum, and it compounds monthly. Okay, so $200,000 into an annuity. The question's telling us it's an annuity. He's paying 5% compound interest, or getting paid 5% compound interest, I should say, per annum, compounding monthly. If he wishes to be paid monthly payments for 10 years, how much will he receive each month? So looking at that information, we need to decide what's what. All right, straight away, the $2,000 is your PV. The 5% compound, obviously you write that in as your percentage, and we're going to be our PPY or our CPY is going to be 12. Okay, and we're doing 10 years monthly, so we've got to do 10 times 12, which just gives us 120, and that'll be our N. So let's go have a look at the finance solver. All right, so to the CAS menu, there's 8 is finance, and then number 1 finance solver, and there we go. So the number was 120, the interest rate was 5%. Remember, we don't have to break that down. 200,000, oh, hang on. Now he's paying it to the bank, so it's a negative value, $200,000. We're trying to work out our payments. We're going to leave a future value or a final value as 0, and it's going to be 12 payments per year. Okay, once you've done that, you just go to payment, press enter, and it should work it out to be $2,121 per month. Okay, so we just write our answer. Monthly payment equals $2,121.31 because you can see that it's a 0 there, so I can round down. All right. The next question is, if he receives a regular monthly payment of $3,000, how long will the annuity last? Give your answer to correct to the nearest dollars. So, back to the CAS. Okay, so this is the information from the previous question. I'm going to remove the payment and write in $3,000 instead. And then I go to number to find out how many payments he will receive if he's getting $3,000 a payment. And it's 78 payments. So again, we change the payment to $3,000. We enter for N, we find N. We've got 78 months, which is more easily counted as 6 years and 6 months. Okay, so now we're going to see what interest rate would allow Joe to have this account last 10 years and withdraw $2,500 each month. So back to the CAS. All right, so we want it to last the full 10 years. So that is 120 in N. We want him to be getting $2,500 per month. So that's a positive value. And what we're looking for is a new interest rate. So we hit enter to calculate that. We find that it's 8.689. So we'll round that off to 8.69%. So again, I changed N to 120 for the full 10 years. I changed the payment to $2,500, a positive value. And then I hit enter to find the new interest rate, which is 8.7%, because the question did ask for 1 decimal place, not 2. All right, that's done. Good luck, guys. Message me if you get stuck.